So for the first question that I'm sharing here, this is actually from 42 February March 2018. Part A of it is to complete the table. Okay, this is the easiest from this type of question. Simply substitute the x value into the equation given above. Okay, then you will get the value as 0, negative 0.17 and 2.4. Okay, so there's a guide here actually to identify how many decimal for you to use. So at most it is 2 decimal. At the very least, unless it is whole number, you need to include at least 1 decimal. Okay, so how do you determine this is to check from the value that was listed in the table. Alright, part B. Okay, after you plot down the points, simply sketch out the line itself. Okay, things to take note that for this type of sketching part, okay, please don't use a ruler to complete the entire thing. Okay, so you need to use your free hand and then do not have those small lines at the side of the answer itself. So this is the draft that I drew out. Okay, so from the first question, part C, use your graph to solve the equation more than equals to 2. Okay, so whenever it comes to this type of question, you must always compare it to the original equation given by the question. So from here, we can immediately know that it is trying to show you that y is more than equals to 2. So simply draw a line, okay, from the point where y more than equals to 2. Okay, so you will see there will be 2 intersection points, and these 2 will be the answer. Okay, so when I'm drawing the graph itself, I already calculated for one small square from the x-axis, the value is actually 0.05. Okay, so I just count and then backtrack it. So my results will be 0.225 and 2.25 respectively. As for part D, okay, so this is the hardest it can be for this type of question, okay, where it involves shifting and adding in variables to fulfill the question. Okay, so over here, okay, the equation 1 over x equals to 7 minus 3x. Okay, first thing that I did was I break down the negative 3x at the right hand side as negative 2x minus x. So when this negative 2 here being shifted back to left hand side, it will become the positive 2x, which is what was shown in the original equation. Okay, then the 7, okay, over at the right hand side can actually be break down into 3 plus 4. Okay, then when I shift the 3 away, so the entire left hand side will be the original equation already. So your new equation itself will actually be the leftover variables, which is 4 minus x. Okay, so the equation of this straight line will be y equals to 4 minus x. Okay, so using this equation that we have gotten, I try to sketch out the line, okay, that was requested by the question. Okay, so I plot down when x equals to 0, my y will actually be 4. When x equals to 4, my y will actually be 0. So this is what I usually do. However, when I look back to the graph, okay, itself, for x it's only until 3. So I cannot use the coordinate where 4, 0 there. So I set another point, which is when x equals to 2, y results will actually be 2 as well. So with these two coordinates, 0, 4 and 2, 2, I can now draw out the last line there okay, and find the intersection. So the intersection results will actually be 0.15 and 2.175 respectively. Moving on to the next question. Okay, this is another type of it where they already drew something there. So let's look at part A, where they are looking for the equation of the line of symmetry. So in order for you to identify the line of symmetry, first you need to understand the concept itself. Okay, basically you are required to imagine there's a mirror there, and the object and the image will be the same when it was being reflected at the line of symmetry. So in our case, this question, our line of symmetry will actually be x equals to 0. Okay, so for part B, they ask you to draw a tangent line where x equals to 0.5. So when x is equals to 0.5, okay, I roughly draw out the tangent line. So there's actually a guide for you to how to draw it. First, after you place down the ruler, okay, you're required to check, okay, both sides, okay, of it must be roughly at the same distance, okay, which is this thing I'm trying to show here. Okay, the first line that I drew wasn't accurate, so I redrew it. Okay, this is much better now. So with these two coordinates, which is 0.58 and 0.12, I can now calculate the gradient of this tangent, okay, using the equation y2 minus y1 over x2 minus x1. So my results will be negative 8. So over in part C, simply substitute the value of negative 1, negative 0.5 and 0 into the equation. Then you will get 0, 2.4 and 4 as the results. So repeat the same thing. Now I sketch this out on the graph. Looking at question D, okay, so they given you a new equation. However, please remember whenever it comes to this type of question, always refer back to its original ones. So the original there, we actually have 10 minus 8x squared. Okay, so you try to adjust the new equation that was given and construct the original equation at one of the sides. So the first thing that I did is actually get rid of the positive 8x squared. Okay, by shifting it to the other side, now I've gotten negative 8x squared. Okay, then the next thing that was missing from the original equation is actually the 10 over there. So now I included 10 of both of the sides. Okay, so they are equal to each other. So when negative 6 interact with positive 10, you will get a balance of positive 4. So the new equation itself will actually be x cubed plus 3x squared plus 4. And question E. Now they have given you another equation. Since you already noted that 10 minus 8x squared will actually equivalent to x cubed by plus 3x plus 4. Okay, now you can use this equation to make adjustment to this x cubed plus 5x plus 2 that was given by the question. So I break down the 5x into 3x plus 2x. Okay. So the first thing that I did was to shift away the positive 2x to the other side, then I'll get negative 2x over there. Then the next thing is that compared with the equation that we have, you actually need to have positive 4, which we only have positive 2 there. So repeat the same thing, add 2 on both of the sides. Okay, then your new equation will actually be y equals to 2 minus 2x. So I set the variables when x equals to 0, y will actually be 2, when x is 1, y is 0. So with these two coordinates, I drew out another line . Okay, then the interception here will actually be negative 0.375. Looking at the third question that I'm reviewing today, okay, as usual, for part A, simply substitute the value of negative 0.5, 1 and 2 into the equation. Then you will get negative 2, negative 0.2 and 2.5 as the results. Then sketch out the coordinates and the line itself. It should look something like this. So over in section C, by drawing a suitable tangent, find an estimate of the gradient of the curve x equals to negative 2. Okay, so from the point where x equals to negative 2, I draw a tangent line. Using the same concept that I have earlier, both the left hand side and the right hand side of the tangent line you drew must be at the same distance. Okay, it's just estimation. You don't have to draw it very accurate. Okay, so now that we have two coordinates here, which is 0, 3.8 and negative 2, negative 2.8, you can run the calculation of y2 minus y1 over x2 minus x1 and get the gradient as 3.3. And since we already gotten the y-intercept, which is the coordinates 0, 3.8, you can now construct the equation of this tangent to the curve, which is y equals to 3.3x plus 3.8. Okay, and over in section D, use your graph to solve the equation. Okay, compared to the original equation. Alright, so we have x cubed over 3 minus 1 over 2x squared equals to 0. So this is the original equation that was given. So you immediately know that it is referring to y equals to 0. Whereby for the next one, okay, the original equation was actually added with 4. So let's shift this 4 away. Then you will get y equals to negative 4. Looking back to the graph that we have drawn, when y equals to 0, my x-intercept will actually be 1.1. Whereby when my y is negative 4, my x-intercept will actually be 0.3, negative 0.3 and negative 2.35. Question E is actually uncommon and slightly trickier. Okay, so the first thing that I did here was to change all of them, the denominator into the same, which is 6x squared. Then, by shifting the 6x squared to 0 part, okay, multiply by 0, then you get rid of the denominator already. So you will have 2x to the power of 5 plus 24x squared minus 3. Then compare this to the form that was given over there. Immediately you will know your a is actually 2, your b is 24, and your n here will be 5. So now in question 5, alright, so first part as usual pretty straightforward, just substitute the negative 2 and 3 into the equation, then you will get y results as negative 3 and 17. Then construct the curve itself. Okay, this will be the end of your first step. So in question C, a straight line through 0, negative 17 is a tangent to the curve. Okay, so this is the question where most students fail to answer. Okay, so always plot down the point first and then try to join the point to the curve. Okay? See which part of it you are able to construct a tangent line. So as usual, follow the tangent line rules. Okay, both sides of the tangent line you draw to the curve must be at the same distance. Okay, and the intersection here will actually be 2, 1. So with the information that we have, which is these two coordinates now, we can now calculate this gradient, which is 9, and the intersection is actually negative 17. So combining all the information that we have, we'll know that y equals to 9x minus 17. will be 5. So with these two coordinates, we can now draw out the last line and find the intersection with the curve. So there will be 3 intercepts, which is negative 2.2, negative 0.55, and 2.7. Okay, so this will be it for this topic. I hope that you're able to understand this and how to solve all these type of questions already, because it holds quite some weight, okay, in your exam score. Usually it's like 10 and above. So try to nail this part. I wish you all the best in your upcoming examination. Thank you.